about these two questions, and you can see the questions. I wrote the lambda naught m, and lambda naught m is the limiting molar conductivity. So this topic is from the chapter electrochemistry. We are dealing with the limiting molar conductivity of weak and strong electrolyte. So here we are talking about the Kohlursch law. Kohlursch law, which is the law of independent migration of ions, or Kohlursch law of limiting molar conductivity. So what is the molar conductivity and what is the limiting molar conductivity? Let's see that मैंने अपने previous video lectures में I discussed about the topic limiting molar conductivity and molar conductivity. When we are taking 1 mole of electrolyte in a conductivity cell, then we are saying that we are measuring the molar conductivity, and at infinite dilution, when we are making the concentration zero, means the dilution is infinite, then that time we are saying it is the limiting molar conductivity. So here we are discussing about the Kohlursch law. So let's see that what is Kohlursch law. Kohlursch law, which is the one of the topic of the unit electrochemistry class 12th. So from the chemistry, so Kohlursch law of independent migration of ion. Kohlursch law of independent migration of ion and migration of ions. This is also known as Kohlursch law, or that is limiting molar conductivity. So law of limiting molar conductivity or law of independent migration of ion. So here we are discussing about the conductivity of a strong electrolyte when the concentration is almost zero and the dilution is infinite. So here the molar conductivity is represented by lambda m having the naught over there, then this is the limiting molar conductivity. So what Kohlursch is saying, that if the strong electrolyte is there and when it will get dissociate into ions, the total molar conductivity is the sum of the individual conductivity of the ions. So what Kohlursch is saying, that the limiting molar conductivity of an electrolyte, the limiting molar conductivity of an electrolyte कोई भी हो सकती है. Here we are talking about the strong electrolyte. The limiting molar conductivity of an electrolyte means KCl, NCl, even magnesium chloride, calcium chloride. So the limiting molar conductivity of an electrolyte is the sum of the individual conductivities of the cation and anion. So what it says कि जो हमारा strong electrolyte है, जब वो dissociate होगा ions में, जितने भी ions में वो dissociates होगा, उन दोनों का जो sum होता है, that is the limiting molar conductivity of that particular electrolyte. For example, here we are talking about the limiting molar conductivity, जिसको कि हम इस तरह से represent करते हैं, and we are talking about NaCl. NaCl हमारा इलेक्ट्रोलाइट है. तो what is that? The limiting molar conductivity of sodium ion, which is having a positive sign on it, plus limiting molar conductivity of Cl minus. So this is the कोलार्च law. What it says कि किसी भी इलेक्ट्रोलाइट का अगर आप लिमिटिंग मोलार कंडक्टिविटी निकालना चाहते हैं, and limiting molar conductivity I just explained, the conductivity when dilution is infinite, means it is having a too much solvent. Now ions are free to move because the interionic space is covered by the water molecule, so these ions are free to move that. So here the limiting molar conductivity of NaCl is the sum of the limiting molar conductivity of cation as well as the limiting molar conductivity of anion. ये तो ऐसा इलेक्ट्रोलाइट है where the number of cation after a dissociation is 1, means we are getting only one. Unit formula में we are having the 1 and Cl1. अगर if we are having the number of, अगर यहाँ पे हम ऐसा इलेक्ट्रोलाइट ले लेते हैं, फॉर एग्जाम्पल इफ वी आर टेकिंग calcium chloride, here the number of cation, means the number of cation is equal to, यहाँ पे हम इसको V plus, and the number of anion is represented by V minus. So the limiting molar conductivity of calcium chloride will represented as limiting molar conductivity of, as I said, V is the number of total number of cation, is V plus multiply with C2 plus limiting molar conductivity of, here we are having, this will come in the front, here the total number of cation and total number of anion, and that is Cl minus. So what we are having, total number calcium में 1 है, that is the limiting molar conductivity of CaCl2 calcium chloride 1, because the calcium 1 number multiply with limiting molar conductivity of calcium plus here V minus the total number of anions and multiply with limiting molar conductivity, और V कितना है यहाँ पे 2, we are having 2, so simply we are writing 2 here, and this plus would be here 2 and Cl minus. So this is the way how we are calculate the limiting molar conductivity of an electrolyte, that is the sum of the individual conductivities of anion and cation, and if this is the total number of anion after the dissociation and V minus the total number of anions after the dissociation, then how we will calculate the molar conductivity like this. Now the kohlaursch law is also explaining that if we are taking a same cation and different anion, then the pair will have almost the same type of molar conductivity. So let's see that what it's saying. What is the molar conductivity for especially sodium and potassium units? What it says, if we are having the sodium as a cation and this is the anion plus and potassium, and if we are having this sort of formula, the इनका जो what we can say, तो इनको माइनस करके जो हमारा आंसर आएगा, that will be the same for other pair. So what it says कि the difference जो हम माइनस करेंगे, the difference of sodium and potassium. Sodium, sodium and potassium as cation with same anion will constant. क्या रहेगा? Constant रहेगा. For example, we are taking NaCl minus KCl. यहाँ पे मैंने सोडियम के साथ भी क्लोरीन लिखा है और पोटेशियम के साथ भी क्लोरीन लिखा है. Whatever the difference is there, the difference is almost 23.4 Simon centimeter square per mole. Will be same if we are taking Ni, sodium iodide minus potassium iodide. It will be the same. इसके लिए भी सेम ही रहेगा. So कोलार्स लॉ इज सेइंग कि अगर हम सोडियम और पोटेशियम अलग अलग कैटायन लेते हैं बट एनायन हमारा सेम है, हम कोई भी एनायन ले लें, वी विल हैव द सेम लिमिटिंग मोलार कंडक्टिविटी. जो डिफरेंस रहेगा वो सेम रहेगा. फॉर एग्जाम्पल यहाँ पे हम NaBr minus KBr and that will be the same 23.4 Simon centimeter square per mole. Same Simon centimeter square per mole. And one more prediction by the Kohlaursch is that if the cation is different और हमारा जो anion है it may be different, then what would be the molar conductivity? So what it says, अगर हम यहाँ पे सोडियम के साथ मैं डिफरेंट एनायन ले लेती हूँ. फॉर एग्जाम्पल आई एम टेकिंग NaBr minus NaCl. Now the cation will be same but the anion will different and will have क्या हो जाएगा 8.2 Simon centimeter square per mole. Now we will have this limiting molar conductivity and कोई भी cation हो सकता है but anion will be different. दोनों में जब हम difference निकालेंगे तो cation will be the same. So here we can say KCl minus KBr, that is 8.2 Simon centimeter square per mole. So these are the some of the prediction by the Kohlaursch, and we are saying the Kohlaursch law of independent migration of ions or the Kohlaursch law of limiting molar conductivity of the an electrolyte. So what it says, अगर हम यहाँ पे कोई भी cation ले लेते हैं, for example we are taking the अमोनियम हाइड्रोक्साइड, हमने एनाइन अलग ले लिया है माइनस दैट इज अमोनियम क्लोराइड ले लेते हैं एंड इट विल बी द सेम. So these are the some of the prediction by the Kohlaursch law. And now let's see or have a look on these questions before I will wrap my video. मोलार लिमिटिंग मोलार कंडक्टिविटी ऑफ, यहाँ पे अमोनियम हाइड्रोक्साइड का हमने लिमिटिंग मोलार कंडक्टिविटी लेना है. आई जस्ट एक्सप्लेन व्हाट आर द वेरियस प्रेडिक्शन बाय द कोलार्च लॉ अबाउट द लिमिटिंग मोलार कंडक्टिविटी. सो इट सेज द लिमिटिंग मोलार कंडक्टिविटी हमने किसका निकालना है यहाँ पे, अमोनियम हाइड्रोक्साइड का. which of the option is correct? Let's see that what is the ionic dissociation of ammonium hydroxide. क्या हो जाएगा, that is limiting molar conductivity of ammonium hydroxide. It will give you the limiting molar conductivity of ammonium ion. It will be having a plus sign on it, plus the limiting molar conductivity of hydroxide anion. This is further dissociated into this type of ions. Now, which of the option is giving this one? Let's see the first one. Let's see or check with the first one. What is the first option is saying here? First option, that is limiting molar conductivity NH4 plus, we are, हमने इसको यहीं पे ही अलग अलग करके लिखना स्टार्ट करना है, so that we will must have this value here. Limiting molar conductivity of hydroxide ion plus limiting. Now ammonium chloride को हम किस तरह लिख सकते हैं? Limiting molar conductivity of ammonium ion plus limiting molar conductivity of Cl minus, and the last one is limiting molar conductivity of H plus minus, because minus will दोनों के साथ हो जाएगा, minus limiting molar conductivity of Cl. यहाँ पे कुछ भी ऐसा नहीं है which is getting इसे हम कट कर सकते हैं, ये दोनों तो प्लस हो जा रहे हैं. We will have a 2 number of this, and this hydroxide किसी के साथ भी कट नहीं हो रहा है, and we are having only this cancellation. Now what we are having? Ammonium ion plus hydroxide ion, along with that we are having one more ammonium and the hydrogen ion. So means the first option is not correct. Let's see the second option. What is second option here? That is limiting molar conductivity of ammonium ion, and we will divide it with limiting molar conductivity of Cl minus plus limiting molar conductivity of sodium ion plus limiting molar conductivity of hydroxide ion minus limiting molar conductivity of sodium and minus limiting molar conductivity of Cl. Now see this one, यहाँ पे limiting molar conductivity of chloride ion is getting cancelled out with this one. Limiting molar conductivity of sodium ion will cancel out with this one, and here we are having the limiting molar conductivity of ammonium ion plus limiting molar conductivity of hydroxide ion, means this is matching with this. So out of आगे हमें जाने की जरूरत ही नहीं है, because we got the answer here. The option second is the correct option, where is the limiting molar conductivity of ammonium hydroxide is equal to limiting molar conductivity of ammonium chloride plus limiting molar conductivity of sodium hydroxide minus limiting molar conductivity of sodium chloride. So this is the correct option, as I just explained how Kohlaursch said that कि किसी भी electrolyte का when we are doing the dissociation, the individual ion का जो summation या addup या sum होगा, that will give you the limiting molar conductivity of that electrolyte. Now let's come to the second question. The molar conductivity of NaCl, HCl and sodium acetate. यहाँ पे हमें 3 इलेक्ट्रोलाइट दिए हुए हैं और साथ में उनका मुझे लिमिटिंग मोलार कंडक्टिविटी भी दी हुई है रिस्पेक्टिवली. मीन्स NaCl का दिस वन है, HCl का ये वाला है एंड सोडियम एसिटेट का ये वाला है. एंड द मोलार कंडक्टिविटी ऑफ, हमें एसिडिक एसिड की मोलार कंडक्टिविटी निकालनी है with these three. हमें how we can find it out, because we got the sodium acetate, hydrochloric acid and sodium chloride. So let's see that how we can find it out. For second question, let's see that. So solution to this one, NaCl. So limiting molar conductivity of NaCl equal to limiting molar conductivity of Na plus limiting molar conductivity of Cl minus. Then we are having the limiting molar conductivity of HCl, which can be written as limiting molar conductivity of hydrogen ion or proton and limiting molar conductivity of Cl minus. And we can also write the value here, that is 126.45 Simon centimeter. Simon centimeter square per mole, and this is also 426.16 Simon centimeter square per mole. Then the sodium acetate is given there, that is limiting molar conductivity of CH3COONA. It can be divided into two type of ion, that is limiting molar conductivity of acetate ion plus limiting molar conductivity of sodium ion. So, and what is the value here? That is 91 Simon centimeter square per mole. So these are the values given here, and we have to find out, किसका find out करना है हमने, limiting molar conductivity of CH3COOH. हमें एसिटिक एसिड का फाइंड आउट करना है. So let me write the lambda properly. So here we are writing the lambda. Now what is the limiting molar conductivity of acetic acid? That is CH3COO acetate ion plus limiting molar conductivity of हाइड्रोजन आयन और प्रोटॉन. मीन्स मुझे ये चाहिए और ये चाहिए, रेस्ट मुझे कुछ नहीं चाहिए. सो व्हाट वी विल डू दैट, ऐसा कुछ लिखें कि ये यहाँ से कैंसिल हो जाए. सो व्हाट वी कैन डू, वी विल ऐड, हम इसे इक्वेशन 3 लिख लेते हैं. दिस इज इक्वेशन 2 एंड दिस इज इक्वेशन 1. सो व्हाट वी विल डू, हियर वी विल ऐड इक्वेशन 3 with equation 1. So what we will do, add equation 3 and equation 1, इन दोनों को हम प्लस कर लेंगे. तो what we were getting here, that is limiting molar conductivity CH3CO minus plus limiting molar conductivity of sodium ion. ये मैंने इक्वेशन 3 ऐसे लिख दिया है. Let me write it little bit down. Plus limiting molar conductivity of sodium ion, and while we are adding, और अगर हम ऐड कर रहे हैं then we are getting the double, so we have to be minus this one, minus, subtract कर लेते हैं. Subtract equation 1 from equation 3. इक्वेशन 1 को 3 से माइनस कर लेते हैं. तो इक्वेशन 3 मैंने यहाँ लिख दिया. नाउ वी हैव टू डू दी माइनस यहाँ पे करेंगे, दैट इज लिमिटिंग मोलार कंडक्टिविटी ऑफ सोडियम आयन माइनस लिमिटिंग मोलार कंडक्टिविटी ऑफ Cl. मैंने इक्वेशन 3 से इक्वेशन को माइनस कर दिया है. एंड नाउ ऐड इक्वेशन 2, और इक्वेशन 2 को ऐड करेंगे. तो व्हाट इज इक्वेशन 2 हियर, दैट इज प्लस लिमिटिंग मोलार कंडक्टिविटी ऑफ H प्लस लिमिटिंग मोलार कंडक्टिविटी ऑफ Cl माइनस. सो ये इक्वेशन 2 से ले लिया है, ये इक्वेशन 1 है और ये इक्वेशन 3 है. सो यहाँ से ये दोनों अपोजिट साइन में है, कट हो जाएंगे. ये दोनों भी अपोजिट साइन में कट हो जाएंगे. एंड व्हाट, जैसे कि मैंने भी लिखा भी है कि हम इक्वेशन 3 को 1 से माइनस कर देंगे. सो 1 को 3 से माइनस कर देंगे. मीन्स यहाँ पे थर्ड वाला इक्वेशन हमारे पास ये वाला है. तो 91 माइनस 126.45 and then add 426.16. सो हम यहाँ से इन दोनों को ऐड करके इसे माइनस कर लेंगे. तो here we can find the molar conductivity 426.16 add 9100. What is the answer? That is, and then we have to subtract 126 from it, and that is 1 and 7 and 0 and 9 and 390. So यहाँ पे what is the limiting molar conductivity of acidic acid? That is CH3COOH equal to limiting molar conductivity of acetate ion plus limiting molar conductivity of that hydrogen ion, that is equal to 390.71 centimeter square per mole. So this is the way how we can calculate the limiting molar conductivity of various electrolyte. If we are provided with the one of the strong electrolyte, then we can find out by using Kohlaursch law the limiting molar conductivity of other electrolytes. So Kohlaursch law is using to find out the molar conductivity of the weak as well as the strong electrolyte. So मिलते हैं नेक्स्ट वीडियो में with other or more numericals based on the Kohlaursch law. Till then, you take care and subscribe my channel for more videos.